Hello, everyone. I hope everybody is okay and everybody is healthy. We just want to talk about increasing, decreasing functions. That's chapter 3 of Calculus and Vectors course. We start by simple definitions. A function f of x is increasing on open interval of x1 comma x2 if for every x1 less than x2 we can conclude that f at x1 is also less than f at x2. This is just a definition. In the graph here, right here, it shows part of a graph of a function, y equals f of x. You see that x1 is less than x2. Let's say x1 is like 2 and x2 is like 5 or something. And that f at x1 is also less than f at x2. So we see that if x1 is less than x2, this implies that f at x1 is less than f at x2. This means that the function is decreasing. I'm sorry, increasing. On the other hand, if a function is said to be decreasing, it means that over that interval of x1 comma x2, for every x1 less than x2, it can be implied that f at x2 is greater than f at x1. So in this second diagram, you see that x1 is less than x2, but f at x1 is greater than f at x2. So these kind of functions are called decreasing functions, whereas the other one is called increasing function. Now, what is interesting about these is that if you draw tangent lines at different points, let's say I draw a tangent line somewhere here, all these tangent lines, you would see that they are rising from left to right, which means that their slope is positive. And slope is determined by the first derivative in calculus, as you very well know. So this means that y prime is actually greater than 0 whenever the function is increasing. On the other hand, when we have a decreasing function and at different points I draw different tangent lines, those tangent lines are actually falling from left to right, which means that their slope is negative. And the negative slope means, of course, the first derivative is less than 0 or negative. Now, we just have to remember that if the first derivative of a function is positive, the function is increasing. If the first derivative is negative, the function is decreasing. That's all we need to know for now. Now, in this next example, we're going to determine the intervals over which the function is increasing and decreasing. As you see, a fourth degree quartic function is given, and we want to find out over what interval it's increasing, over what interval it's decreasing. Obviously, our criteria is the first derivative, as I mentioned earlier. So we're going to take the derivative of this function to begin with. So I'm going to go f prime of x, or actually y prime, equals 4x cubed minus 12x squared minus 16x, as you very well know. Now, we have to determine that this cubic polynomial is positive or negative over what interval. For this purpose, we're going to set the derivative equal to 0. When I do that, let me show the work. When I set it equal to 0 and I factor 4x, the GCF, greatest common factor, out, I end up with x squared minus 3x minus 4 equals 0. We may be able to factor the quadratic trinomial here. Two numbers add up to -3, product is -4. Obviously, it's going to be -4 and +1. So if you set each factor equal to 0, either 4x is 0, or clearly x minus 4 is 0, or perhaps x plus 1 equals 0. This means that we have three x values. One is x equals 0, one is x equals 4, and one is x equals 9, where the first derivative is 0. Now, still we don't know over what interval y prime is positive, so that we announce the function is increasing over that interval, or we don't even know where the function is decreasing because we don't know where the first derivative is negative. So in order to determine this, we are going to construct a chart here. So the chart I'm going to construct is going to be like this. we have x in the top row, and it fluctuates, like x can vary from negative infinity to positive infinity, but we have these three roots of the first derivative, which -1 was one of them, 0 and 4 the other one. I list them in the top line. Then I'm going to subdivide this big interval of set of real numbers into different subintervals. So the first factor I had was 4x, the next one was x minus 4, and then I have x plus 1. I list them here in my chart, in my table. And of course, the product of them would be y prime, whose plus minus sign I'm very much interested in, to tell you the truth. So here, 4x is equal to 0 at 0 clearly. X minus 4 is 0 at 4. X plus 1 is 0 at -1. And wherever these factors are 0, obviously y prime is 0. So I'm going to place all those zeros here. And if x is greater than 0, 4x would have a positive sign, clearly. So I put plus on the right-hand side of 0 and minus on the left-hand side. If x minus 4 is 0, that happens at x equals 4. Well, x minus 4 is 0. If x is more than 4, x minus 4 will have a positive sign. But if x is less than 4, such as 3 to 1, then we're going to have a negative sign for x minus 4. I record that in the chart. Similarly, I put the plus minus signs for the next binomial x plus 1. And now the product of these three negative signs will give me a negative sign as the product, or the sign for y prime actually, because y prime was nothing but the product of those three factors. And negative times negative is positive, positive times positive is positive. We end up with negative here and positive over there. So finally, we succeeded in finding the sign of y prime over different intervals. So we're going to say, we're going to make a judgment about y itself. So I'm going to add another row to my chart, and that will be explaining what is happening to y. I'm going to say, because y prime is negative, so y prime is decreasing. DEC doesn't stand for December only, it stands for decreasing. And plus sign, y prime is positive, it means that the function is increasing. INC doesn't stand for incorporation only, it stands for increasing. And then we have decreasing back again and increasing. So the arrows actually will show how the graph behaves. So now, to write the very final answer, we're going to say f of x is increasing. You have to excuse my ugly handwriting. It's not something new. F of x is increasing over the interval from -1 to 0. And then we're going to find the union of that interval with the other one, 4 to positive infinity. And we can say f of x is actually decreasing over the next interval, which is from -infinity to -1, and then from 0 to 4 back again. So these are the intervals of increase, decrease for the quartic function given to us. I hope you understood how we find the intervals of increase, decrease for a polynomial function. Thank you.